Hi there. It's Chem Coach Powers here, and today we are going to talk a little bit more about acids and bases. So let's go ahead and get rolling here. All right, this is section 9.2, and it's about the reaction that acids and bases undergo as they interact with each other. So you're going to identify the products of a neutralization reaction. That's the kind of reaction that we call the interaction between an acid and a base. And then we're going to explain why neutralization reactions don't result in a neutral pH. Well, if they're called neutralization, why aren't they neutralizing, right? And then we're going to explain why a salt is not just sodium chloride, NaCl. That's the kind we're familiar with, but there's lots and lots and lots of different kinds of salts. So first of all, reactions that are called neutralization reactions are reactions between an acid and a base. Now, we've given you an example here. This is a typical one where you have sodium hydroxide and hydrochloric acid reacting in the presence of water, and they're going to produce the ions. And the ions that they produce are the sodium ion. Oops, let's go back there. They're going to produce the sodium ion, the hydroxide ion, the chlorine ion, and then the hydronium ion. Okay. Now, this is the typical way that you see this reaction drawn out. Okay. When we give you a neutralization reaction, we're saying, hey, sodium hydroxide and hydrochloric acid form sodium chloride and water. Now, this is the total neutralization reaction. This one has broken it down into the different ions. And so it kind of gives you a better picture of how it breaks up into the ions and then forms the two ions that are still in solution, and then the new product, which is water. Okay, so this is a double replacement reaction, and water is a product in this case. Okay, so these are usually forming salt and water, right? So neutralization reactions oftentimes form a salt and a water. So in this case, the salt is sodium chloride, and so that is a type of salt, but there are many other types of salts. Salt is defined as an ionic compound that is the result of a neutralization reaction that consists of a cation and an anion bonded together. And so some examples that are not are hydroxides and oxides, okay? Those aren't considered salts. Why? They're considered bases because when they react or when they get into a solution of water, they're actually forming hydroxide compounds. And so they consider those bases instead of salts, okay? So that is what a salt is. And so that's a huge, huge number of different types of compounds, lots and lots of different types of salts. So here are some examples of different types of salts. We've got aluminum sulfate, ammonium sulfate, calcium chloride, potassium chloride, sodium carbonate, sodium bicarbonate or sodium hydrogen carbonate, sodium stearate. You're going to see that in some soaps, and sodium lauryl sulfonate, also what you'll see in something called detergents, which we typically are just calling them soaps when we are referring to them in common everyday language. But there's a difference between a detergent and a soap, and we're going to talk about those differences in our next lecture. But these are all different types of salts. And it's amazing to think that these probably are things that we've never really thought about as being salts. And there are many, 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 many more. You'll notice that almost all of these they're going to have a cation, right? So you can see the sodium. I keep going crooked. The sodium, that's the cation. And you'll notice that we have a couple other cations, potassium and calcium. Over here we have aluminum, and then here we have a polyatomic ion, the ammonium. So we have a cation and an anion. And the anion in this case is, the sulfates, the chlorides, carbonates or hydrogen carbonates. And then over here, we have some different types of cations. These are molecular compounds. And we don't have to really talk about that in detail here. But when we are getting salts, and we're going to pull a salt and then sell a salt, we're not really doing like a neutralization reaction to actually get that salt. What we're doing is we're pulling it out of the ground. We're basically getting a mineral that is formed naturally, and that's where we get our salt. So if I'm making, these different types of salts, typically I'm finding them from the ground, finding them in nature, and using those. All right, so those are important for various different types of functions of neurons and muscles as well. Okay, so just kind of think about why salts are important in your body, and they're important for the functioning of neurons and muscles. Which ones? Well, you probably heard of getting potassium from bananas, right? That's like a potassium chloride. You probably get that one from the food that you eat. Other types of salts you can get from the food you eat as well. So remember that neutralization reactions don't just result in a neutral solution. The final pH depends upon the strength of the acid or the base, and it depends upon the concentration of the acid or the base. So if I have a really concentrated, strong acid, and then I start to put a weak base into it, they're not going to neutralize each other. Okay, the weak base is going to cause a smaller change in pH to that, strong acid. So just keep in mind that neutralization reactions, although they're going through a neutralization process, it doesn't mean that the end result is neutral. Okay, the reaction itself is the mixing together of those compounds, but it doesn't necessarily result in neutrality. And then we have this term called a titration. Okay, and basically this is a very specific type of controlled neutralization reaction in which we take a known amount of one substance, okay, being either an acid or a base, and then we use it to determine an unknown amount of another substance, whether it be a base or an acid. So I could say, hey, I've got a known amount of acid and I want to figure out what the concentration of this unknown base is. That's what you would use a titration reaction for. So it's a specific type of neutralization reaction where you have a controlled amount of one substance to figure out an unknown amount of another substance. Okay, so we use titrations to determine concentration, and we try to get to a point where we are equal. Okay, this is called the equivalence point. Okay, the point in which you have the original amount of acid equaling the original amount of base. So if we're putting them together, eventually they neutralize each other, right? Well, if I put a strong acid in the strong base, I should, if I have an equal amount, my equivalence point is going to be a pH of 7. However, if I put a strong acid and a weak base together, I'm going to get an equivalence point which is less than pH of 7. In other words, this thing is still going to be acidic. Okay, and again, think about that. Strong acid, weak base, I'm going to end up having an acidic result. Strong base with weak acid, when I hit my equivalence point, I'm going to have a pH that's bigger than 7, which means that my end result is going to be a little bit basic. Okay, so why is that important? Well, you'll get into more details in chemistry on this, but the idea, again, is for you to kind of wrap your head around the idea that, the concentration and the strength are both things that tie into whether or not you end up getting neutralization. So in this case, you can kind of see with some litmus paper. This litmus paper has been tested, and it was red when it was reacted with the acid, and this one has changed blue when it reacted with the base. But if I put it into a neutral solution, the idea here is that it's going to be neutral. It's not going to actually react at all. And so actually, and this is not a litmus paper. This is pH paper. But the interesting thing is, if let's say you took that sodium hydroxide and you took that hydrochloric acid and you put exactly equal amounts of them together, whereas they could be both really dangerous, and caustic and could hurt you. Once you put them together, it's just salt water. And so you could literally take an acid and a base and pour them together and then drink it, and it wouldn't be harmful. Okay, just salt water. It's crazy. All right, so what did we learn today? It's a pretty short lecture today. Can you identify the products of neutralization reaction? Again, usually a salt and a water, okay? Explain why neutralization reactions don't always result in a neutral pH, because you can have strong and weak together, and they're going to not balance out equally, right? Explain why a salt is not just sodium chloride. Well, we have lots of different salts because it's a cation, all right, of one substance and the anion of another substance coming together to form a new product, okay, that's still going to be an ionic compound that's dissolved in water, but it is not just sodium chloride. Lots and lots and lots of different types of salts. All right, so that's what we're doing today. Quick and easy, all done. Get out of here. God bless you. Have a great day and be kind to one another.